derivative to identify the open intervals on which the function is increasing or decreasing. Use the derivative. Well, the first thing we have to do is to actually determine the derivative. Okay. Are you needing to go back to see something? No? Okay. So use the derivative on this. So the first thing we're going to do is write the derivative. It's one of the easier ones you've had to deal with. There's no composite functions, no products, no quotients, no chain rule. Four x cubed minus 4x. Okay. Use it to identify the open intervals on which the function is increasing or decreasing. If the function is increasing, the derivative is what? Positive. If it's decreasing, the derivative is negative. What's between that negative and positive? 0. If I know where the derivative is 0, then on one side it could be positive, on the other side it could be negative. If I know where the 0 is, if you go back to here, if I know where this is at 0, then if I look at the derivative of values less than that, and they come out to be positive values, then I know that the function is increasing. If I look on the other side of that horizontal tangent line point, and I choose a point greater than, an input value greater than the one that creates a 0 derivative, hence a horizontal tangent line, and I see that the derivative's value is negative, then I know that the function is decreasing. We're going to do that. We're going to find out where the function has 0 value, where the derivative, has 0 values. If I know where the zeros are, then I test on either side of those, and I can then determine if it's increasing on the other side or increasing on the other side of the point where it is 0. So let's see here. So the second thing we're going to do is set the derivative equal to 0. So I have 0 equals 4x cubed minus 4x. Use your algebra. We could factor out a 4x. Anyone try this? Factor out a 4x, and we have then 4x, the quantity x squared minus 1. If I know that product is equal to 0, and I have two factors, which factor is 0? Stephanie, which of those factors is my 0? Either one could be? Okay, because I don't know which one for sure. So if the 4x is my 0 factor, then that means x is 0. If, by chance, the x squared minus 1 is my 0 factor, then I've got x minus 1 and x plus 1. Which of those factors is going to make my product 0? Kevin, which one? X minus 1 or x plus 1? Mm-hmm. Either one again, yeah. So x minus 1 is 0, which means x is 1. Or, I'm not trying to trick you, I'm really not. Okay. Or x equals negative 1. So I end up with three values where x is equal to 0. Let's take our inspires, add a page, another graph page, and let's graph this function. I gave you x to the 4th power minus 2x squared. I'm going to change the window. So let's see here. I'm going to make it oh, we'll make it something like, how about negative 2 to 2 scale by 1, and oh, maybe negative 0.5 to 5 scale by 1. Choose what you want, but you know, we'll see if this works here. Oops, I guess 2 wrong, didn't I? So let's do something else. We'll just make this one, we'll make it negative 1. That's too, I'm going to do one more adjustment. You guys can follow my lead if you want. Negative 1.5. There we go. Okay. Now, we're looking for where, let's see, it says use the derivative to identify the open intervals in which the function is increasing and decreasing. Do you see the function decreasing anywhere? Yep, right over here. Okay, all the way down to here, and then it's like the first one I gave you, then we have a second one here. Increasing here and here. Between the decreasing and increasing, you've got a point where if I draw a tangent line, slope of that tangent line would be 0. Got one up here and got one down here. Where do you suppose, or what do you suppose the inputs are at those points? Take a wild guess as to where you think. Yeah, that's what I'm guessing too. Okay, so I'm going to put that right here, and I'm going to go in and, well, let's see, maybe it won't do this for me. I was hoping I could do a coordinate. Yep, it's doing a coordinate. Okay, so I'm just going to do coordinates there. And I'm going to, let's see, you think at negative 1? Because that's what we found. Okay, so right down there. You think at, what did you say, 0? Okay, so let's do it. That looks pretty good. And over here then at 1. Okay,